Hello dear student, I am Varun Kumar Nishad from LPM school. In this video, we are going to discuss about the some natural occurring acids. Before that, as we know that, dear student, during the study of chapter 2, we are discussed about the indicators, chemical property of acids and bases, and what will happen when the metallic carbonate and metallic hydrogen carbonate are react with acid, and what will happen when the acid or bases react to each other, and what will happen when the acids and metallic oxide are reacts to each other. And after that, we have also discussed about the what happens the bases react with non-metallic oxide. And after that discussion, we have also discussed about the how we dilute the concentrated acid and concentrated base. After the bases or a concentrated acid or bases add into the water, and after that we have also done how we dilute the concentrated acid and concentrated base, and this process is known as to decreasing the concentration of H plus ion in acid to decreasing the concentration of OH minus ion in the base, that is called dilution. And after that we have also done how we identify that how acid and bases are strong. So on the basis of strong, which acid which contain maximum amount of hydrogen ion concentration, that is called strong acid, and which base, that is, and which hydroxide and which solution that contain maximum amount of hydroxide ion, that is strong bases. So, and how many quantity is present in a particular solution of acid and particular solution of bases. On this basis we have need universal indicators. The universal indicators are made up from various type of mixture of indicators. So after adding the addition of universal indicator into the acidic or basic solution, we have find the different types of color, and on this basis of this color we have find the concentration of acids and bases. And after knowing the pH value, the particular things which are used in our daily life, the particular pH of the regular usage substances, that is coffee, carrot juice, tomato juice, saliva before pH, saliva in our mouth after meal, and 1 mole of hydrochloric acid, 1 mole of sodium hydroxide, and of sea water, what is the pH of sea water. After knowing the some general substances pH, we have also done the importance of pH in everyday life. In this segment we have touched the various types of aspect, that is, or plants, animals, pH sensitive, and pH of soil in your backyard, pH in our digestive system, and pH cause change as tooth decay, and pH help in defense mechanism of the plant and animal. So after this discussion we have done about the various aspects, and after that we have discussed about the some natural occurring acids. So this is a natural sources, that is vinegar. Vinegar contains acetic acid and this pH is 3.9. and orange is a fruit, and it contains citric acid, and that pH value is 3 to 6. It is a depend on the concentration. And tamarind contain tartaric acid. tamarind contain tartaric acid and its pH value will be 2.3. It is highly acidic. And tomato vegetables that contain oxalic acid, and oxalic acid pH will 3.3. And sour milk, that is curd, which contain lactic acid, and it pH range 3.4 to 3.6. Now the lemon is also contain the citric acid, and which this acid pH is between 3 or 6. It also depends on the concentration of H plus ion. And on the string which contain methanoic acid, it also called formic acid. And its formula is Ch-2. So this formic acid, it is also formic acid. So this formic acid is released into our victim skin, and it causes pain and irritation. So after that, this pH value will be 3.5. So in this way, the some natural occurring acid and their natural sources and their pH values. And after that, we have done some questions which related to our already reading topics. Now, dear student, some questions on the discussed topic. Suppose question is that you have a two solution. The two solution which A and B, which pH is 6 and B pH is 8. So question is, which solution has more hydrogen ion concentration? Which solution which have more H plus ion concentration? So it will be answer that it is a very simple. So B का जो pH है, अब pH रेंज इस तरह से आप देख सकते हो, मिडिल में 7 होता है, then 6, 5, 4, 3, 2, 1 and 0. So when we move from 7 to 0, it is increasing up H plus ion concentration, and when we move from 7 to 14, that is 8, 9, 10, 11, 12, 13 and 14. So here is 8. So after that, when we move from right 7 to right, it increasing the OH minus concentration. So it will be given the solution A pH is 6. So now which have more hydrogen ion concentration? किसमें concentration हाइड्रोजन का मैक्सिमम होगा? इधर जब आप जाते हैं राइट साइड में तो H प्लस आयन का कॉन्सेंट्रेशन घटता है. अगर आप लेफ्ट की तरफ जाएंगे, 7 से लेफ्ट की तरफ आएंगे तो आपका H प्लस आयन कॉन्सेंट्रेशन बढ़ेगा. तो आपका मैक्सिमम हाइड्रोजन आयन कॉन्सेंट्रेशन पीएच वाला जो सॉल्यूशन है वो है सॉल्यूशन ए, दैट इज pH 6. Now, which of this is acidic and which one is basic? तो इसमें बेसिक कौन है? दैट इज उसमें OH माइनस कॉन्सेंट्रेशन मैक्सिमम होना चाहिए तभी तो वो बेसिक होगा. दैट इज सॉल्यूशन, ये तो ए हो गया, ये आपका होगा सॉल्यूशन बी. दैट इज pH 8. In this way we can answer of this question. So question number 2, that is, so question number two, that is, what effect does the concentration of H plus ion have on the nature of solution? अगर कोई solution है, suppose solution है, solution which have more H plus ion on concentration. The solution which have more H plus ion concentration. And what is the nature? What is the nature of this solution? तो solution जो है वो क्या है, उसके पास H plus ion concentration maximum है. Means that H plus ion concentration है तो acidic character show करेगा. तो solution will be acidic. Solution will be acidic, and so the solution which contain more hydrogen ion concentration that affect the nature of acidic solution. Now third question, that is, do basic solution also have H plus ion concentration? That is, वो क्या hydrogen ion contain करता है? Question mark. If yes, then why are these basic? अगर कोई solution है, now question is that do basic solution have H plus ion? Do basic solution have H plus ion concentration? H plus ion concentration. So if yes, if yes, why we called these solution basic? So answer will be, as you know that during the discussion of pH value and universal indicator, we have also discussed about this graph like structure, that is this graph like structure. So it represents the H plus ion concentration and it represents the OH minus ion concentration. So here is a 7. If you suppose that it is a neutral. So in basic solution there is also in basic solution there is also H plus ion contained. Here is also seen in this diagram, but in very low amount. In very low amount or low quantity. And OH minus present in very high quantity comparatively. That's why it regard as it called sorry, it called basic solution. Basic, that is called basic solution. So in this way we can identify and we can give the answer of this question, related question, and another video we will discuss